Good evening and welcome to Unacademy's live YouTube classes. I'm Rashmi Amma and welcoming you to YouTube classes. We students, we have already started. We started with alcohols, phenols, and ethers. We have completed alcohols and phenols. We have learned ethers preparations. We are in reactions of ethers, right? Okay, we have learned one reaction, that is how ether reacts with hydrogen halides. Now today we are going to learn electrophilic substitution reactions of ethers. Before I start with the class, let me tell you something about Unacademy classes. See, Unacademy is surfacing our classes in YouTube's as special classes, even as Unacademy Plus classes. If you want to have a comprehensive batch like physics, chemistry, mathematics, biology, and physics, chemistry, biology. If you want a comprehensive batch, then you have to subscribe to Unacademy Plus classes. Now, I also told you Unacademy YouTube classes. Now, these classes are free classes for you. The half-an-hour class, free classes. Same way in Unacademy Plus classes, under Unacademy platform, there are special classes. Unacademy special classes also free classes. They are also free classes. There is also Unacademy Plus class. See, when YouTube and the special classes, only when you get link, you can go to that classes and learn. Even if it is free, you can only get the link, you can learn. Okay, but Unacademy Plus classes, it's a comprehensive batch, live class with a complete syllabus preparation. Okay, most of it is comprehensive batch, which you have to subscribe. You can subscribe for 12 months, 6 months, 1 month. Okay, Unacademy Plus class is best suited for Karnataka CET aspirants. Okay, where you will be taught above and beyond what is required for Karnataka CET. It's not just NCERT, above and more than what is required. Okay, complete syllabus preparation. So you get premium content in affordable pricing. Look at the prices. So you can subscribe for 12 months, you can subscribe for 6 months, or even for 1 month. Okay, comprehensive batch, complete preparation. So if you're going for 12 months, you have to pay 12,375 rupees. Students, when you subscribe, if you use my referral code Rashmi 2020, okay, use my referral code Rashmi 2020. So when you use my referral code, you will get 10% reduction. So in this amount, you will getting 10% reduction. So added benefits are there. You will get reduction. Okay. So you go for the referral code. So you'll get reduction. Okay. You can go for 6-month plan where you're paying 10,125 rupees. So when you use my referral code, it is actually less than 10,125 rupees. Or 1 month plan you can go for. So whichever plan you take. Okay. What are the benefits of this plan? One is structured live classes, dedicated live doubt clearing sessions. Theory is taught well. After that, every class, and you will have 10 to 15 or 10 to 20, depending upon the subject, the concept. You will have MCQ. So you have regular quizzes, you have test series, daily practice problems, full-length mock tests, which will help you in self-analysis. Not only I make you realize how important, where you are. Okay, will help you prepare you to answer MCQ. Also, in some concepts, whether you understood or not, you will be able to analyze yourself, self-analysis. Now, if you know that some concept you need to study more. Okay, this chapter need to be worked more. What you can do? So with a single subscription, you have unlimited access to Unacademy Plus online classes as well as recorded classes. So if that chapter online class is been taken up, you can go and study there, or you can go access to recorded classes in that particular concept. Recorded classes you can access, and you can go to the class again. Okay, so you have unlimited access. As long as you have subscription, 24 hours you can use Unacademy Plus platform. Recorded classes, offline, online, you can learn, go through it again, and you can learn and relearn. Okay, so that is one of the perks of Unacademy Plus subscription. Students, if you want to have a wholesome study, complete preparation, okay, not only one subject, other subjects also, you can subscribe. By subscribing, use my referral code, so you get all benefits, added benefits. Okay, any doubts, you can put the question here. Okay, if you have a doubt, you can ask me. Okay, yes. Any doubts, students? Okay, let's start with our class. Okay, so once again, welcome to Unacademy's live YouTube classes, and I'm Rashmi. I'm going to continue with electrophilic substitution reactions of ethers. We are talking about ethers. Now, what kind of ether? Aromatic ether I'm talking about here. So we are going to take anisole. Okay, so you have C6H5OCH3. This is anisole. Methyl phenyl ether. methyl phenyl ether or anisole. Okay, yes. Now, alkoxy group, before we go to electrophilic substitution reaction. Okay, why electrophilic substitution reaction? Because benzene ring is present, which is nuclear, which acts like a nucleophile. So when nucleophile is present, to electrophile only you can substitute. Now, where do you substitute this electrophile? To the ortho position or para position, because the OR group, OCH3 group, is ortho para directing. See, oxygen, okay, oxygen C6H5 OCH3. This is anisole. Oxygen has two lone pairs of electrons. And oxygen is attached to an sp2 hybridized carbon atom, which is part of benzene ring. So oxygen is attached to an electron withdrawing group. So the lone pair of electrons, or one of the lone pairs of electron of the oxygen, is in conjugation here. Okay. So if I have to show you, it will be like this. Let me show you here. Okay. This is double bonds, OCH3. Oxygen has two lone pair of electrons, is in conjugation with the benzene ring. So benzene ring pull the lone pair of electron towards itself. So never two double bonds exist together. Pi electrons never sit next to each other. So this pi electron go to the next carbon atom, resulting in the first resonance structure, this. So ortho position becomes negative. See, ortho position is negative. So double bond OCH3 you have. Oxygen lost one electron to carbon, so plus charge. Okay, so these two bonds are here. So these electrons are never now remain in one carbon. So it will move to between carbon. Okay. 1 second, students. As I was telling you, OCH3, lone pair of electron drawn here. So you will have first canonical structure minus double bond O CH3. This is plus. So this electron will come between these two carbons. So the next canonical structure. So this electron will go to para position. So remember, ortho position was first. Now second canonical structure, para position is electron rich. So double bond is here. This was already there. O CH3 plus. See, double bond is shifted here. Okay. Again, the electron cannot concentrate in one carbon atom. So this electron will move between the carbon. So when the double bond comes here, this double bond will move here. Okay. So the third canonical structure you have here. Now a next ortho position. Okay. Like this. CH3 plus. Okay. See, if you look, okay, final structure is this. This will come back here. So the electron move back to oxygen, giving rise to anisole molecule. Anisole. See, OCH3 like this. So if you look at the canonical structures, ortho, para, ortho positions are electron rich. So when electrophile approaches anisole, ortho positions and para positions are comparatively electron rich. So the electrophile will be directed by OCH3 to ortho and para positions. So we call OCH3 or OR in general, OR, alkoxide group or alkoxy group. Alkoxy group. See, OR minus is alkoxide. Alkoxide. Okay, charge carrying. OR is alkoxy group. Alkoxy group. Alkoxy group. OR group is alkoxy group. So alkoxy group directs the incoming electrophile to ortho and para position because they are ortho para activating. See, they activate ortho and para positions. Okay. So now we are learning electrophilic substitution reactions. So first electrophilic substitution reaction is halogenation. Halogenation, we can just call it as bromination because bromination, okay, bromine in ethanoic acid is taken. Bromine in ethanoic acid. Okay, bromine dissolved in acetic acid. That's why ethanoic acid is nothing but acetic acid. CH3, COOH, two carbon atoms. So eth, carbon-carbon single bond, A in a functional group is COH, so oic acid. So ethanoic acid is nothing but acetic acid. So bromine is dissolved in acetic acid when treated with anisole, or anisole is treated. Anisole undergoes bromination with the bromine in ethanoic acid. So bromine, okay, from bromine, Br plus is directed to ortho and para positions. So you get a mixture of product. Okay, so get ortho bromoanisole and para bromoanisole. See, this is anisole, is it not? This molecule is anisole. So with respect to this ortho bromoanisole and para-bromoanisole. So you get a mixture of product. Okay, ortho and para-bromoanisole is obtained during bromination of anisole. Okay, so this is the first electrophilic substitution reaction. Okay, now the second electrophilic substitution reaction. Okay, is Friedel-Crafts reaction. So Friedel-Crafts reaction, two reactions we are going to learn. One is Friedel-Crafts alkylation. This is Friedel-Crafts alkylation. Now why do I call it as alkylation? Or okay, this is in general alkylation, or we call it as Friedel-Crafts methylation. Why methylation? Alkylation because Rx will be used. If Rx is used, because this is general Rx, so alkylation. Since you have used CH3Cl in particular molecule, alkyl halide is used, you call it as methylation because methyl group becomes the electrophile. Okay, methyl group is the electrophile. So it's called as methylation. So if methyl chloride or ethyl chloride or in general alkyl halide, halolkins is used, okay, for Friedel-Crafts reaction, then such Friedel-Crafts reaction is called as Friedel-Crafts alkylation. Here in this case, Friedel-Crafts methylation, because methyl group is going to be added to ortho and para positions. Since it is Friedel-Crafts reaction, the reaction requires Friedel-Crafts catalyst, anhydrous AlCl3. This is Friedel-Crafts catalyst. Reaction takes place in an inert solvent is carbon disulfide. So when anisole is treated with methyl chloride in the presence of Friedel-Crafts catalyst, anhydrous AlCl3 in solvent CS2, you get mixture of two products, ortho substituted product and para substituted product. So CH3 substituted to ortho, okay, and CH3 substituted to para. Okay, now when this CH3 is there, okay, when CH3 is there in the into the benzene ring, what you call this CH3C6H5CH3, you call this molecule as toluene. So with respect to CH3, this becomes this is carbon number 1, this is carbon number 2. That is ortho is carbon number 2. So you get ortho methoxy. This is methoxy. Ortho methoxy toluene. So this will be with respect to CH3. This will be para. So this is carbon number 1, 2, 3, 4 or para. Para methoxytoluene. Or this is 2 methoxytoluene or 4. Para is 4 methoxytoluene. Now, if you look at the product, you see, even in this case, okay, when you have, 2-bromoanisole and 4-bromoanisole, see, with respect to this is 1, 2 bromoanisole or ortho-bromoanisole. With respect to this 1, 2, 3, 4 bromo or para-bromoanisole. Para product is major product because the two bulkier groups which is attached to the benzene ring are as far away as possible. They are so less repulsion, more stable. So your para products are major products. Same thing is seen here. See, when two bulky groups are sitting next to each other, they experience repulsion, steric repulsion, steric hindrance also, steric repulsion also, electronic repulsion. Okay, as a result, this is the minor product. So ortho product is minor, para products are major because two bulkier groups are in the opposite ends. So that when the distance is maximum, the repulsion is maximum, stability is more. So major product is para products or 4-methoxytoluene is major product. So this is Friedel-Crafts alkylation or in particular Friedel-Crafts methylation. Now if you use, this reaction is called as Friedel-Crafts acylation. When you call it as acylation, when you use the RCOX, general formula, RCOX, acid chloride, acid chloride, halide, acid halide. If chlorine is there, then you call chloride. This X is halide, acid halide. So if you use acid halide, general formula RCOX, okay, then it's called as acylation. Since we have used ethanol chloride, ethanol why 1,2 carbon atom, so eth. Between carbon single bond. See, this is CH3, C double bond O, Cl. Between carbon single bond, so A na, COCl is called as noyl. When you have COCl, the name end with the OYL and Cl chloride. So ethanoyl chloride. So acid chloride name end with the OYL halide. Okay, ethanoyl halide is Cl now. Chloride, ethanoyl chloride. Okay, or acetyl chloride. It's also common name is acetyl chloride. Acetyl. See, from this is acetic acid, CH3COOH. Now OH is replaced by Cl. So acetyl chloride. Name acetyl chloride. Acetyl chloride. Okay. Again, Friedel-Crafts reaction. So anhydrous AlCl3 Okay. Now, so when you use the particular example ethanol chloride, when you use, then you call it as acetylation. Acetylation, because acetyl group CH3CO group is going to be added. CH3CO group. So CH3CO group, CH3 C double bond O with the plus charge. Carbon is carrying plus charge here. Okay, carbon of CO, carbonyl, because COCl bond breaks, Cl will come out as Cl minus. So carbon, see, this bond breaks. This will come out as Cl minus. So carbon lost its electron. So carbon gets plus charge. So this carbon, CO, the carbonyl carbon is bonded to ortho position or para position. See, carbonyl carbon. So when you're writing, you should be very careful. You should never write like this. Okay, you write like this and you write CO, CH3. This is wrong. Okay, the bond is to carbon of CO. So that has to be shown properly. CH3 like this. Okay, same way here. Okay, the carbon of carbonyl group where carbon Cl bond broken, no, that carbon gets positive charge. That is bonding to ortho and para position, because comparatively that is electron rich. So you get two products, mixture of two products. Okay, so this C6H5CO CH3, what is this? Acetophenone, ketone. Okay, so with respect to this is your ortho position, or this is first carbon atom, second carbon atom. So ortho position, second carbon atom. So para position is carbon number 4. See, 1, 2, 3, 4. 1, 2, 3, 4. So you get 2 methoxyacetophenone, or 4, sorry, this is, okay, I wrote ulta. Let me write this. This is 1, 2, 3, 4. Or with respect to this is para. So 4 methoxy or para methoxy acetophenone. This is acetophenone. Ketone. Okay. So you get 2 methoxy acetophenone or 4 methoxy acetophenone. Again, major product is para substituted because bulkier groups at the opposite ends. When bulkier groups are at the opposite end, that will be the major product. Okay. So acylation in general, acetylation in particular, acetyl group, that is CH3CO group, is added. When I say CH3CO group, CO's carbon is the one which is forming bond. CO's carbon is the one which is forming bond with the carbon of the benzene ring. Okay, so that is Friedel-Crafts reaction, Friedel-Crafts alkylation and Friedel-Crafts acetylation or acylation. Okay, I hope this is clear. Both are very, very important. Okay, yes. Now let's go to the third reaction, that is nitration. So 3 electrophilic substitution reactions you have learned now. We're going to learn. One is halogenation, Friedel-Crafts reaction, and third nitration. So you need to use nitrating mixture. So what is nitrating mixture? Mixture of 2 concentrated acids, concentrated sulfuric acid and concentrated nitric acid. So you take a mixture of concentrated sulfuric acid and nitric acid. It's called as nitrating mixture. Nitrating mixture, where NO2 plus will be your electrophile, which is added to ortho position or para position. So you get 2 nitroanisole. So this is anisole, correct? So with respect to then first carbon, second carbon. So this is anisole. Okay. So 1, 2, 3, 4. So 2 nitroanisole or 4 nitroanisole is the product. Okay, 2 nitroanisole or 4 nitroanisole. Or you can also write this as 2 nitroanisole as 1 methoxy 2 nitrobenzene, or 1 methoxy 4 nitrobenzene. This also IUPAC name. So this, okay, you can also write like this: 1 methoxy. See, you take this benzene as your root word. So benzene. Okay. So when you have COCH3 and NO2, COCH3 the first takes the first position. So 1, 2. So 1 methoxy 2 nitrobenzene. So it is 1 methoxy 1, 2, 4 nitrobenzene, like this, or 2 nitroanisole 4 nitroanisole. This is easier, is it not? Okay, so you should know 2 nitroanisole can also be called as 1 methoxy 2 nitrobenzene. 4 nitroanisole is also called as 1 methoxy 4 nitrobenzene. Okay, so this is about nitration. So there completes our reactions of ethers. Reactions of ether is complete. Now let me talk about acidity of alcohols and phenols. Acidity of alcohols and phenols. Let's talk one by one. Now why alcohols? When I say alcohols are acidic, alcohols are weakly acidic. They are weakly acidic. In fact, they are weak acid than water. Water is more acidic than alcohol. That we will discuss why water is more acidic than alcohol. Now, why alcohol is acidic? See, when you call a substance acid, if it releases H plus ion, is it not? Okay, so alcohol, general formula ROH. If alcohol releases H plus ion and it forms the conjugate base OH minus ion, if it releases H plus ion, ease with which it releases H plus ion, then we say it as acid. And easily H plus ion is released when you say stronger acid. Okay, when you call a acid as stronger, if it quickly, easily releases H plus ion. So this hydrogen, if it's released easily, then you call it as acidic. Now alcohol is weakly, but I said acidic. Why it is weakly acidic? Okay, two reasons. First thing is reaction of alcohol with the sodium, strong metal. Okay, strong reactive metal like alkali metals. Alcohol reacts only with the strong metals like sodium. Strong alkali metals like sodium, and it forms sodium alkoxide. So H will be replaced, okay, from ROH. H is replaced by Na. So you get a sodium alkoxide and hydrogen gas is released. Okay, alcohol, that is the primary alcohol. Tertiary alcohol also can react with metal like aluminium. Okay, reacts with aluminium, giving aluminium tertiary butoxide. See, butoxide, aluminium tertiary butoxide. See, Al3 plus, is it not? Al3 plus, aluminium forms plus 3. So, and this ion, when H plus comes out, you get -1. So, to satisfy plus 3 charge, you have to take tertiary butoxide and thrice, because Al is 3 plus, this is only -1. Okay, so interchange. So, aluminium once, the butoxide and thrice. Okay, this is the formula, releasing 3 hydrogen molecules. So, this is one evidence that alcohols are acidic, because they react with sodium and aluminium. They react with the reactive metal like sodium, potassium, aluminium. So all this is an evidence that alcohols are acidic. Okay, that is one. Now phenols, again, phenols also do the same thing. Phenol also react with sodium. Okay, so OH, see, each carbon here has hydrogen. So you have altogether 5 hydrogen in phenol. See, 5 hydrogen, 1, 2, 3, 4, 5. Okay, sorry, not 5, 6 hydrogen, including the 6 hydrogens. But the OH is the one which is coming out as H plus. Okay, so it will form and it reacts with sodium. You get the phenoxide ion, see, O minus ion. Since O minus, sodium, Na plus will remain near it. So you have sodium phenoxide ion. So H will come out as H plus. Then how H2 is formed from 2 molecule to H plus, right? 2H plus. Sodium will come out as Na plus, releasing 1 electron. So 1 H plus will take up from 1 sodium. From second sodium, it will take second electron because 2 sodium. Now they form bond, H2. So when hydrogen comes out, it leaves the electron and comes out as H plus. Now to form H2 molecule, from where do they get 2 electrons? From sodium. Sodium is a reactive metal. It will form Na plus, releasing 2 electrons. Correct? So these 2 electrons are taken up by the proton, forming H2. Okay? So you have phenoxide ion. Phenoxide ion. Phenol is more acidic than alcohol because phenol can even react with aqueous sodium hydroxide. It need not be just reactive metal like sodium. Even aqueous sodium hydroxide solution, okay, can release H plus ion, giving sodium phenoxide ion. So sodium phenoxide is formed because this H plus is acidic, because phenol is acidic. Now the question, I said alcohols are weak. Why alcohols are weakly acidic? See, why alcohols are acidic at all? Because of the polar nature of OH bond. Let's talk about that. Polar nature of OH bond. What is the polar nature? Oxygen being more electronegative pulls this electron towards itself. So it becomes negative, this becomes a positive, right? So in aqueous solution, this bond breaks, giving you alkoxide ion and H plus ion, releasing H plus ion. Now, polarity, because of the polarity of the OH bond, makes alcohol acidic. Now, what makes it weakly acidic? Because of the presence of R group. R group, what is the nature of R group? Electron donating, they donate electron. So, oxygen when attached to an R group, an electron donating R group, the electron density around oxygen is now more because R is giving electron to it. ROH, it has 2 lone pair of electrons. R is giving electron. So the electron density around oxygen is now, electron density is much high. So it did not require these electrons. So what happens? Oxygen will not pull this electron towards itself. So if the electron is not pulled, hydrogen still has its electron. Hydrogen remains with the oxygen as OH bond. So hydrogen cannot come out as H plus ion. Only if these electrons are pulled by the other atom, then only hydrogen can come out. Now since oxygen is receiving electron from R, Okay, the electron density increases. It does not require electron from OH, bonded electrons. As a result, among three classes of alcohols, primary is more acidic than secondary than tertiary, because primary has only one R group, secondary has two R group, tertiary has three electron donating R group. Okay, so as you go from primary to secondary to tertiary, polarity of the OH bond decreases in this order only, because the polarity of the OH bond decreases because of the three alkyl electron donating groups, like this, three groups. Okay, polarity decreases. As a result, the OH bond is not polar, OH bond is not broken, H plus ion is not readily released, so acidity decreases. Okay, that is one thing. Now I also told you water is more acidic than alcohol. Water is more acidic than alcohol. So first point is alcohol is acidic, proven by the reaction with sodium. So, but weakly acidic. Why? Because of the electron donating R group. Now, why alcohol is weakly acidic and less acidic than water? Look at this. What is the difference between alcohol and water? Alcohol has H and R. Water has two R groups. That's the difference. Okay, two H same, but second H, water has H, alcohol has R. R is electron donating, whereas H is not. So that is why water is more acidic than alcohol. Water is more acidic. So it will form OH minus ion and H plus. Okay, so water is more acidic than alcohol. Okay, so that is about alcohol. Now that's what I'm telling you. See, it forms like this. So base OH minus ion. See, if you have alcohol, you dissolve in water. Correct? It forms alkoxide ion plus H plus ion. Correct? No. This alkoxide ion is not stable because of the electron donating group. Electron density is more around oxygen. It is not stable. So when it comes across water molecule, it will take proton from water. It forms alkoxide ion. Okay, will take proton from water and forms ROH. Whenever you have a molecule takes H plus accepts hydrogen, okay, except H plus ion, then it's called as the base. And the one which donates H plus ion is called as acid according to Arrhenius concept, Lowry-Bronsted concept, is it not? Okay, according to Arrhenius, if a molecule produces H plus ion in water, it's called as acid. If a molecule accepts H plus ion or OH minus ion is released, then it's called as the base. This is according to Arrhenius theory. According to Arrhenius, acid is a substance which releases H plus ion in water. Base is a substance which releases OH minus ion. According to Lowry-Bronsted concept, what is acid? If a compound releases H plus ion, that is acid. If a compound accepts H plus ion, that is a base. So if it gives H plus ion, that is an acid. If it accepts, okay, if accepts, that is the base. So giver is an acid. See, water is giving, so it becomes acid. Alkoxide ion, okay, now accepts H plus ion, that becomes base. So the result is ROH, alcohol, is called as conjugate acid, because this can result in this reaction, giving you alkoxide ion. So it's called as conjugate acid because it can release H plus ion. And resulting molecule from water, OH minus, is called as a conjugate base, because now this can accept an H plus ion, forming water. This can accept H plus ion, forming water. So you have conjugate acid base pair. So ROH and RO minus, alkoxide and alcohol, and alkoxide ion are conjugate acid base pairs according to Lowry-Bronsted concept. Okay, so as I was telling you, alcohol is water because the alkoxide ion formed is less stable. It accepts because of the presence of R group. It is less stable. It accepts proton from water, giving you alcohol. So that makes water more acidic than alcohol. This is about acidity of alcohols. Now about phenols. Now what makes the phenol acidic? With the presence of H plus ion. See, this presence of H, which can be released as polarity of OH bond. Now why OH bond is polar? Because oxygen is bonded to electron withdrawing phenol ring, electron withdrawing benzene. So oxygen's lone pair of electron is withdrawn by benzene ring, resulting in resonance structure. See, oxygen is carrying plus charge. Oxygen cannot carry plus charge. So what does it do? To compensate its plus charge, it pulls the electron from hydrogen. So it increasing polarity of OH bond, releasing H plus ion. Okay, so phenol releases H plus ion because of the polarity of the bond. That is first point. Second point is why they are acidic is the resulting phenoxide ion. See, when phenol, because of the polarity, okay, because of the polarity, when phenol loses this hydrogen, forms a phenoxide like this. This is phenoxide plus H plus. The resulted phenoxide ion is stable because of resonance. See, the extra electron will come between oxygen and carbon, okay, the negative charge move. Then the negative charge on the oxygen is not confined to oxygen, it moves in the molecule, so result in the resonance stabilization. So the phenoxide ion is resonance stabilized. So whereas the alkoxide ion, the negative charge is concentrated on oxygen. That is why when it comes in contact with water, it takes up H plus, because our electron is concentrated on oxygen. Whereas here, the negative charge is not concentrated on oxygen, it moves in the molecule like this. Okay, so it is resonance. So resulting phenoxide ion is resonance stabilized. That is why phenol is more acidic than alkoxide ion. Whereas in alkoxide ion is concentrated only on oxygen. Okay, so this makes a phenol acidic, more acidic than water. Last point, okay, presence of electron substituting, or electron donating group and electron withdrawing group. Now, if electron donating group or electron withdrawing group are there, if electron donating groups are present, like in this case, if electron donating groups are present, let's say here electron donating groups are present on the phenol. Since electron groups are present, electron donating groups like CH3, okay, CH3, NH2, OH, all these are electron donating groups. When electron is donated to the benzene ring, it will not take up electron from the oxygen. So as a result, the polarity of this bond decreases. Only if the lone pair of electron of oxygen is withdrawn by the phenol and the phenolic ring, then only this polarity increases. But now phenolic ring is not withdrawing oxygen's electron. Why? Because it is getting electron from the electron donating groups. So polarity decreases, acidity decreases. But presence of electron withdrawing groups like NO2, CN, COOH, CHO, all these groups are electron withdrawing groups. It withdraws electron from benzene ring. So when some other groups are withdrawing electron from benzene ring, electron are withdrawn from oxygen by the benzene ring. So oxygen in turn withdraws electron, this electron is withdrawn and lone pair of electron withdraws. As a result, polarity increases, acidity increases. So electron donating group decreases acidity, electron withdrawing groups increases acidity. Electron donating group decreases. D, you remember. Electron donating group decreases, electron withdrawing group increases. Okay, with this, alcohols phenols chapter is ending. Okay, thank you very much, students, for wonderful audience. I hope you understood. I hope you learned something from this. Okay, keep learning and keep enjoying classes, and please put good words so that I will also get encouraged. Okay, thank you.